now we'll get to the thyroid, which I was just hoping we'd get through the thyroid today, so we should be good. Don't forget, you guys, I have the hormone chart on the website. So if you guys want to print that out, it essentially just says, like, this is the gland, what hormone comes from it, where does it go, how is it made, what does it do? And it's just a way for you guys to kind of organize these whole last sections, because there's a ton of information on all these different glands. Okay, so the thyroid gland. The thyroid gland lies in front of the trachea. Okay, so remember, like, going down the respiratory tract, you have your pharynx or your throat. You go into your larynx. I had to feel like where it was moving. You go into your larynx. And remember, right in the front of your larynx or voice box, you have that large thyroid cartilage. Just below that, you have your thyroid gland. So you'll kind of feel like a nice, smooth thyroid cartilage. And if you go below that a little bit, you feel it's a little bit softer and more bulbous, but you'll feel your thyroid cartilage. So it's literally just right in the front, right here. When we look at the thyroid gland, again, just below the thyroid cartilage, and it has two lobes that are connected by a little narrow kind of an island. Oops, not that much. So it ends up looking kind of like that, kind of like a butterfly, and it wraps a little bit around the trachea, like this. When we look at the thyroid gland microscopically, okay, so if we were to like section this up and cut this up and look at it microscopically, we would see that it's made of tons and tons of what we call thyroid follicles. And I do have a picture coming up, but thyroid follicles are spheres, okay, so this is like a full sphere with follicle cells on the outside, these little cuboidal cells all surrounding the outside, and then a follicle cavity on the inside. Okay, so all of these little cuboidal follicle cells, and then inside is this cavity that's really, it's got this like really gelatinous, thick kind of a fluid with tons of amino acids in it, okay, just packed with amino acids. When we look at the thyroid follicle, the whole thyroid follicle is involved in producing the thyroid hormones. So it's not just like one cell, it's you utilize a cell, and then you utilize the cavity, and then you utilize the cell again in order to produce and release the thyroid hormones. So it's the full thyroid follicle that makes the thyroid hormones. When we look at the thyroid gland, the gland itself is surrounded by capillaries, tons and tons of capillaries. It's very, very bloody. So much so that when you actually look at the thyroid, it's red. Like it appears red because of all of the capillaries that are just surrounding the surface of the organ. And again, these capillaries are really important for any endocrine organ because the capillaries are going to deliver things like regulatory hormones, right? The thyroid only makes thyroid hormone when TSH comes. So we need capillaries to deliver the TSH. And to deliver all of the nutrients that are needed to make the thyroid hormones. We'll see that we utilize a lot of amino acids, we utilize a lot of iodine, so we need the capillaries to bring that stuff in, and then also to accept the hormones, right? If the gland is going to be making a bunch of hormones, you need a bunch of capillaries there to accept those hormones into the bloodstream. So lots and lots of capillaries wrapped around the outside. So here, yeah, so you'll see, like, even on pictures and stuff, we tend to color it red. And that's, the pictures, that's pretty intentional. Like when we do the adrenal glands, you guys will see that they're normally colored yellow because there's so much fat that's stored in them. So these are normally colored red because of all of the capillaries. So this is showing you the thyroid gland. Again, looking at this, so you're seeing like the neck. Here's the larynx, the thyroid cartilage of the larynx. That's the like where the Adam's apple is on a guy that moves up and down when you swallow. And a little bit below the thyroid cartilage, you'll see the actual tissue or feel the actual tissue of the thyroid gland. Again, it's kind of a butterfly shape, right, with the two lobes or the two wings. When we section it up and look at it smaller, this is what we'll see. Okay, this is real. So this is, I mean, it's very, very well organized. Okay, this is an actual thyroid gland that you're looking at. You guys can see that we've got the cuboidal cells are on the outside, and then this nice gelatinous follicle in the middle. Okay, so again, the thyroid is organized into all of these thyroid follicles, cuboidal cells, the follicle in the center, and we'll utilize both the follicle cell and the follicle cavity when we're producing our thyroid hormones, our T3 and our T4. C cells are different. C cells are not related to T3 and T4. C cells are clear cells. We'll see those are important for calcium homeostasis, but those are not involved in thyroid hormone production. They're completely different.
Some of the cells don't have a nucleus.
What's that?
Some of the epithelial cells or the square cells don't have a nucleus.
Where?
On the left.
In the model on the left.
Oh. Oh, like that? Yeah, I don't know the significance of that. It looks like there's one per follicle. So oh no, there's another one over there. I'm wondering if it's like a secretory, like a supportive secretory function. Very possible, but no, I don't know, that's a really good point. I can find that out. You can find that out.
Yeah. Mine looks like it on the real one too.
Yeah.
On the bottom.
Yeah, right here. Wait a minute. I'm like staring at the picture trying to find it. Yeah, it does look like it. It does look like you can see like right here there's a nucleus. Possibly right here. And sometimes you like on the epithelium where you see the goblet cells. You know how like on the pseudostratified epithelial tissue, how there's a goblet cell, like a mucus producing cell. So it's possible, and this is a really thick viscous colloid, so it's possible that those cells are producing that really thick viscous fluid to put in, to fill up the follicle. That's most likely what's happening. They're just like supportive roles like that. But I don't want to tell you that for sure because I'm kind of making it up. I'm not making, I mean, I'm theorizing. Theorizing sounds better than making it up. Okay, so the thyroid gland. The thyroid gland produces thyroid hormones. Okay, we'll see that the thyroid hormones are T3 and T4. Now, thyroglobulin is a protein that's extremely important in the production of thyroid hormones. If you remember the very, very beginning when we first started talking about the different types of hormones, we said that thyroid hormones are examples of what kind of hormones, what class? Peptides, amino acid derivatives, lipid derivatives. Amino acid derivatives. Good guess. I don't know if it's a guess or not. Sounded kind of. They're amino acid derivatives. So the thyroid hormones are based on the amino acid tyrosine. They're relatively small, based off of tyrosine. When we look at thyroglobulin, it's a large globular protein that has a lot of tyrosine in it. So remember, proteins are just like these big strands of amino acids. So we've got tons and tons and tons of amino acids here. And when we look at thyroglobulin, we'll see that a really high percentage of these amino acids happen to be tyrosine. So we could say that. Like those are all tyrosine. That's a really high percentage. So thyroglobulin is a really big protein with a lot of tyrosine. It's made by the follicle cells. So it's made by the cells that are around the outside. And then the thyroglobulin gets secreted into the follicle cavity. Now, when the thyroglobulin gets put into the follicle cavity, we see that it also has a bunch of iodide ions that it puts in there with it. Because both are going to be required for the synthesis of thyroid hormones. The thyroglobulin, which essentially we just want the tyrosine, but the tyrosine and the iodide hormones, the iodide ions, have to get combined in order to make the thyroid hormones. Okay, so we make thyroglobulin in the follicle cell, and then we put the thyroglobulin and a bunch of iodide ions into the follicle cavity. In the follicle cavity is where we actually will start attaching iodide ions to the tyrosine molecules. Okay? And that's how we're gonna start. We'll go through the whole process, but that's essentially how we're gonna make T3 and T4. Now, thyroid hormones, T3 and T4. Thyroxine is T4, or we also call it tetraiodothyronine. Tetraiodothyronine. Tetra meaning 4, iodo, so 4 iodide. Okay, hence we call this T4. What we see with T4 is that T4 contains 4 iodide ions attached to the tyrosine. The majority of the T4 that gets secreted from the thyroid hormone, the majority of the thyroid hormone that gets secreted is T4. The T4 can then be converted to T3 in the body, but as it's coming out of the thyroid gland, the majority of the thyroid hormone is going to be T4. T3 is triiodothyronine. Tri meaning what? 3. So that has 3 iodide ions on tyrosine. So we'll look at, well, actually, I'll do it. Let me look at the picture. This is giving us a ton of information. Okay, so I'm going to kind of talk through the whole process. It's showing us the production of thyroid hormone, T3 and T4. So we'll talk through this whole process, and then I'll kind of point out the details to you. I would never expect you to like actually list out step 1, step 2, step 3. But I want you to understand the gist of it. Like, know that iodide ions are important. Know that TSH stimulates this. Just like the key facts we'll point out as we go, or at the end. So, again, we're going to be trying to make thyroid hormone, right? So we're looking at the thyroid gland. The thyroid gland is made up of all of these follicles. We've got the cells, the follicle cells, and then inside the follicle cavity. And we're going to utilize both the cells and the cavity when we're producing our thyroid hormones. When you're looking down here, this is the cell, this is the cavity up here, and this is just showing you the bloodstream. Because remember, we said they're covered with capillaries. We've got tons and tons of capillaries all over the thyroid gland. So here you see that we have a TSH-sensitive ion pump. This just means that this is an ion pump that takes iodide and pumps it into the thyroid follicle. And it's TSH-sensitive. That means that TSH turns it on. What's TSH? Thyroid stimulating hormone. Where does that come from? Excellent job, the anterior pituitary. So TSH comes from the anterior pituitary gland, travels to the thyroid gland. When TSH binds, it binds in multiple places, but when TSH binds, it turns on this ion pump. Okay, so that then iodide ions get pumped in to the follicle cell. This is really the only place in your body where you're using iodide, but you use a lot of it here. The TSH is also going to stimulate the production of our thyroglobulin. Okay, so you'll notice here we're going to recycle amino acids later, but we combine amino acids with tyrosine because we said that thyroglobulin has a lot of tyrosine. Right? Tyrosines are a really important amino acid for thyroid. And we make more thyroglobulin. So we've got a bunch of iodide, we've got a bunch of thyroglobulin, and we put them together and bring them into the follicle cavity. Okay, so essentially you could say that this is exocytosis, right? Because it's exiting the cell, leaving the cell to go into the cavity. So we have the exocytosis of iodide ions and thyroglobulin into the follicle cavity. Then when we look at the follicle cavity, what happens here is we add these iodide ions to our tyrosine. So remember, this was my thyroglobulin, right? But it's really way bigger than that. There's a ton of amino acids. And everywhere I put a star, that's where I've got my tyrosine. So say this tyrosine, I added 1, 2, 3 iodide. This one I added 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Okay, so that's what I did. Now I've got this big thyroglobulin with a bunch of iodide attached in all these different areas. Essentially, what I have there is a bunch of T3 and T4. Right? Everywhere that I have a tyrosine with 3 iodide, I have what? T3. Everywhere I have a tyrosine with 4 iodide, I have T4. It's just that they're all connected right now, right? I haven't actually like separated them from each other yet. So then still, this is all going to be under the influence of TSH. TSH stimulates all of this. We can take this thyroglobulin with the iodide and take it back into the follicle cell. Okay, so this is now if we want to release it. We produced it, now if we want to release it, we'll bring it in. Again, that's endocytosis because we're bringing it into the cell. And then we utilize lysosomes. Remember, lysosomes just have digestive enzymes. So they've got enzymes that go in and break things up. So the lysosome comes in here and it just starts to break this apart. Right? So they'll say, done, break, break, and it'll break all of these bonds to free up all of my tyrosine. Now I have free, right? That's T3. What was this one? What's this one? Okay, you get it. What do I have more of? T4. Which one's more potent? T3. Okay, so I've got a bunch of T3 and T4, and then they will just diffuse out of the cell into the bloodstream, and then they'll go work. This is showing you the carrier protein. Remember we said that carrier proteins are really important for thyroid hormones, and we'll talk about them more in a second. But essentially that's the point. So keys are the follicle, the whole follicle is involved in the production of thyroid hormones. Thyroglobulin is the protein that's important. What amino acid do we utilize from the thyroglobulin? Tyrosine. What ion do we put on it? Iodide. How many? 3 or 4. What hormone stimulates all of this? TSH. What hormone stimulates the uptake of iodide? What hormone stimulates the production of thyroglobulin? What hormone stimulates the release of the thyroid hormones? Beautiful. Where does TSH come from? Good. So that's the gist, right? I want you to understand the point of all of it. So that if I ask you like which of the following is false, and I give you like a random thing about calcium ions being attached to tyrosine, you would know that that's wrong, okay? Because it's not calcium ions, it's iodide. Or if I tell you that a patient who's deficient in iodide wouldn't be able to make enough cortisol, no, they wouldn't be able to make enough thyroid hormone. Yes?
Is there any reason why the thyroglobulin has to have the iodide attached inside the cavity rather than in the cell, and both components can be out in the cell?
I'm sure there's a reason, but I don't know it offhand. I was just theorizing about it. I think it possibly has something to do with osmolarity of the cell, because there's a lot of this that's stored. So if you've got a ton of this stored inside the cell, now your cell's super crowded, and you're going to start affecting the osmolarity of your cell. Whereas if you just store a bunch of this in the cavity here, it's kind of out of the way until you need it. And then when you need it, you can just come digest it and go. But that's just a theory. But the body doesn't do anything for no reason, so there definitely is reason. Stop asking questions I don't know. God, you guys are making me look stupid. I'm just kidding, your questions are good. I'll go look them up so that next semester I'll be like, oh, let me tell you this. And I'm just gonna add more so that their tests are every semester thanks to you guys' questions.
So does that have anything to do with goiters?
Yeah, we'll talk about a goiter in a second. Yeah, we're gonna talk about hyperthyroidism and Graves' disease. And a goiter is just, like you can see the lump in the neck, but that's from a really, really enlarged thyroid gland. You can actually get it with hyper or hypo.
It's just the gland that in a goiter that?
The gland, the thyroid gland enlarges. Like you can see it, you can palpate it, it can get really big. So this, guys, is, what time is it? Can't see the clock. Few minutes. This is just showing us the full cycle, just to show you guys how all of the different glands kind of come in together and work together and how it's all involved. So just for thyroid hormone, remember we're starting up with the hypothalamus. The hypothalamus is releasing our thyrotropin releasing hormone. That goes to what organ? Anterior pituitary then releases what? TSH. Okay, so here's your anterior pituitary releasing TSH. TSH targets the thyroid gland, remember it increases all of it. The uptake of iodine, production of thyroglobulin, production of thyroid hormones, release of thyroid hormones. So now we have T3 and T4 coming out. Okay, they would have little iodine attached, oops, sorry, not that one, iodine attached to them. And now we have enough T3 and T4 and we're back to homeostasis. All right guys, sorry, we got 2 minutes. I'm gonna use every last second. So remember, we said that the thyroid hormones travel through the bloodstream attached to carrier proteins. Very, 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 very little thyroid hormone is actually free. The vast majority, over 99% of it, is actually bound to hormones. So thyroid binding globulins, TBGs, are what bind most of the thyroid hormone in the bloodstream. It's kind of a general, like generic name, but thyroid binding globulins are gonna bind or hold or carry about 3/4 of our T4 and a little bit less of our T3. So most is bound by thyroid binding globulins. Transthyretin and albumin will bind whatever's left, or most of whatever's left. And again, less than 1% of the thyroid hormone is traveling unbound. Okay, so very, very little, the T3, even less of the T4 is traveling through the bloodstream unbound to a carrier protein. Remember when we talked about binding proteins and how they kind of create this like bank account or this reservoir of hormone in the bloodstream, we said that only the unbound thyroid hormone can actually leave the bloodstream, right? When it's bound to its carrier protein, it's stuck in the blood. It can't leave and act. It also isn't going to be filtered out by the kidneys when it's bound. And a lot that also affects metabolism of it. So essentially you just have all of this thyroid hormone that's kind of sitting around in your bloodstream, hanging out and waiting until you need it to work. Again, we said that there was an equilibrium between the bound and unbound concentrations. So, you know, if you have all of those are bound and then you've got this one little unbound one, this is the only one that's going to leave the bloodstream and go work. The rest of them are stuck here. But as soon as this guy leaves and goes to do its job, then we upset the equilibrium and this one then loses its carrier protein and now it's unbound and it can work. As soon as it leaves, we've upset that equilibrium, this one loses its protein and it can work. So it's like you've got all of this built up thyroid hormone that's just hanging out in your bloodstream. Again, we call that a hormone reserve. And for thyroid hormone, it's about a week or up to a week. So if I took my thyroid gland out right this second, I would still have a week's worth of thyroid hormone in my bloodstream because of all of that bound hormone that's present. All right, we'll stop here.